My name is Ashley Ward, and I'm the Engagement and Outreach Associate with the Internet of Water. So welcome. We're thrilled to have you. A few administrative notes for today to remind all of you that we are recording the webinar. So therefore, if you want to watch it later, it'll be shared with all of you via email that you registered on, and we'll also have it on our YouTube channel and on the link available on our website. A couple of other administrative notes. During the webinar today, if you have an administrative question, please place those questions in the chat, and one of us will respond to you quickly. If you have a question related to the content of the webinar or for one of the speakers, please place that question in the Q&A. For those of you that are watching the webinar today using WebEx instead of Zoom, you may place all of your questions in the chat. Also, we're going to have some interactive or activities that we'll walk you through today. And during these activities, I'll make sure to monitor the chat and the Q&A closely in case you're having any technical problems or have a question for the speaker. Okay, so this webinar series is hosted by the Internet of Water's peer-to-peer network. The peer-to-peer network is a community of practice for participants from agencies and organizations across the country to learn from each other and share their successes and lessons learned about modernizing their water data infrastructure. Currently, we have about 100 members of the network that represent more than 30 states, and we would encourage you to join. To join the peer-to-peer network, there'll be links at the end of the webinar slides, but also you can go to our website, internetofwater.org, under Connect and Peer-to-Peer Network. So we hope you'll consider joining us. I also want to remind you that this is part 1 of a part 2 series. Part 2 is tomorrow. If you have not registered for both parts and you would like to attend both parts, please register for part 2 as soon as you can. Also, for today's webinar, we'll be placing the link to a shared folder for those of you who did not receive the email or do not have it handy, so that you can access the materials for today's workshop. Okay, so for today, we will have 2 presentations by Kyle Onda, who is the data architect for the Internet of Water. We also have from CUAHSI, the Consortium of Universities for the Advancement of Hydrologic Science, Dr. Jared Bales, who's the Executive Director of CUAHSI. And so I'm going to turn it over first. Oh, excuse me. Tomorrow, the 2 speakers are Otto Abdullah from the Water Data Exchange of the Western States Water Council and Ryan James of the same organization. So I'm going to turn it over now to Kyle, and we'll get going. Thank you so much.
All right, hello everyone. Thanks for that introduction, Ashley. I'm going to move things over to share my screen. Let's make sure that's working. Okay. Just to check, Ashley, are you seeing the slide and not the presenter view?
Yes, I'm seeing the slides.
Okay, great. So thanks for joining us again. So I'm going to just give a brief presentation on what are metadata and why are they important. And I'll get into some detail on different aspects of metadata that are important to think about and some tools to help curate and publish metadata. So, oops, right. So I'll cover what are metadata, why is it important, how to structure metadata, and some metadata publishing tools. And so what is metadata? The short kind of pithy answer using the term meta, right, is it's data about data. But really it's structured data about data. And a classic example and analogy for metadata is the old library catalog card, right? So back in the paper days, libraries had these card catalogs where each card described a book or an object within that library, describing certain things about it, and from things like the title and the author and the publisher to some details within, like its topic or its, its size, its number of pages, and then its call number, right? Its identifier. And, why was that so important? Well, because of the same reasons that metadata is important in this digital era. You need metadata for discovery. Okay, you need terms to be able to search by, to filter through when looking through data. You probably want to search by title, by keyword, by subject, by period of time, things like that. It's also important for exchange, right? You need to know things about the data before you can send it to other people or be sent it. You need to know about its file size, about its file format, about what kind of web services requests that you need to make. You also need it for administration. You need to know about who is actually allowed to use this data, under what conditions can you copy it and redistribute it. What is the time period for which this data is expected to be published or valid for? And then you need lots of information on how to use data, on how to interpret it. And that is all different kinds of data about data. So in terms of discovery, right, we need to be able to search for data by elements, like its identifier, its type, its title, its subject and topic, its publisher, its author. And particularly when we're talking about water data, right? Its temporal coverage, when is it about, and at what interval is that data, and spatial coverage, where is that data about? Right, and that's the kind of stuff that's analogous to what's on our library card catalog cards. Also important for exchange. Metadata specifies things we need to know for sending and receiving data, like file formats, links to the download pages for downloading the data in those different formats, and maybe descriptions of the API used to call that data in a more automated way. It's also important for administering that data. We need to know who is allowed to use this data and for what purposes. There might be commercial restrictions or something that you need to communicate. These are usually in some version of a license. You can specify how the data needs to be cited. You can let users know what version of the data it is and where previous versions can be found or not. And also important are point of contact information. So where should questions about the data be directed? And finally, metadata can specify important things to know about how to use data and interpret data. So standard kind of project metadata about like why the data was created or for what purpose, how it was collected, was it a survey, is it satellite imagery, is it aerial photography, is it a sensor, is it a manual read, what kind of instruments were used, what is the data about, what is the data's quality, is it provisional, is it quality controlled in some way? And then you also need kind of the attribute data. If we're talking about tabular data, what are those column headers and what do they mean? What can we expect the data values in each of the columns to be? This can really be important for use and can help with data cleaning for end users. And so that metadata covers a lot of important things. And so it's also important to structure it in a coherent way for both humans and machines or computers to interpret. So, and all of these things are sort of elements of metadata or things that you can use to think about structuring metadata. So first, a schema. A schema sounds like an esoteric word, but it just means a list of elements in metadata. So a good example is the Dublin core elements, which is kind of a key basic way to describe information resources. And these 15 things are the core elements, and the Dublin core, which you can explore at dublincore.org, specifies many, many more metadata elements. But these are by far the most commonly used in data publishing. And right, and so a schema is literally just a list of those things. Then there are standards, and there are standards, you can call them content, value, and structure. So content standards are definitions of metadata elements and how they should be generated. So you can think of it as just a better description of the schema. So this is an excerpt from the Dublin core specification of its schema. So we have here the element that's labeled type. You'll notice it itself has a URI, which stands for uniform, uniform resource identifier, which is basically a way to unambiguously identify something using the format of a web address. And you'll see that the type is not just its label, but its definition, and also has a comment that recommends how to populate it. So in this case, it says to use a control vocabulary. And I'll get to what a controlled vocabulary is, because that's the next kind of standard, a value standard. So this is basically the list of terms that's allowed to populate maybe a particular element of a schema. So a good example is the ISO 19115 topics. ISO 19115 is a metadata standard for geographic or geospatial data. And it has a list of 14 specific topics that you're allowed, or that should be allowed, to populate the metadata element topic. And many people find them too vague, but that's just an example of a value standard. And finally, there's structural standards, which are sort of the definition of a format to encode metadata in, so that it's machine readable. The broadest kind of examples are just the basic kind of internet media types. Common examples for metadata being XML and JSON, and more recently JSON LD for linked data, which will become more important during tomorrow's presentation. And someone might ask, why should the metadata be machine readable? And a big part of the answer is because if you want your data to be discovered more easily, it's very good for that metadata to be incorporated into metadata catalogs. And many of these metadata catalogs actually can be populated automatically by web crawlers. And so Google, for example, now has this constantly growing and automatically growing catalog of metadata called, data sets. So Google Dataset Search. And you can search it by things like download format, by keyword, obviously, topic. And that's populated automatically by its web crawler going to websites that have data that have machine readable metadata inside. And then finally, at the bottom, there's the data dictionary, and some metadata standards call this something else, like a feature catalog or entity and attribute information. And this is basically a value standard for the data itself, and that's good to communicate in the metadata. So here's an example from the metadata for USGS streamflow statistics. The link to this metadata entry is at the bottom there. And you see embedded in the metadata are these this nested list of attributes. So in this data set, there's a column called site number. And then this metadata file tells you that the definition of that site number is a unique number for that site. And it tells you that the entity that made this definition is the US Geological Survey. And it says the domain, which is essentially the value list that's allowed, is that it's an 8-digit code that identifies the site. So you see here, this really helps with interpretation of data, because if you were to see the tabular information and have site underscore number, it might be unclear what that means. But since you can cite the metadata directly, you know what that means. So going for examples of those things I've talked about. So metadata schema and standards, some common ones to be aware of in the water sector are the Dublin Core, which is pretty general purpose. I'll link to that here. There's also the ISO 19100 series. ISO 19115 in particular is for geospatial information. There's also the FGDC standards, or the Federal Geospatial Data Committee, which has a long list of standards that both they endorse and are in the process of codifying for endorsement. And then there's also schema.org, particularly schema.org / datasets. Schema.org is an interesting technology that was built by Google, Microsoft, and Yahoo about 10 years ago to give guidance to web publishers, so website publishers, to embed metadata in their websites to allow their own search engines to automatically collect metadata from the websites. And so schema.org / datasets is the subset of that that is supposed to be helpful for cataloging data sets. And so it's kind of similar to these other ones, but more general, less rooted in the scientific community, but still useful to take advantage of if you want your metadata to be discoverable on the internet. So controlled vocabularies and data value lists. These are super important and not often published enough with data, but they can be difficult to create if you're not involved with the data creation process from the ground up. So this is really something to make your data providers aware of, to at least make and publish their own as needed, which I put on the bottom here. But even better idea, to cite existing controlled vocabularies. So for example, the observations and data, the ODM2 controlled vocabularies are great for hydrologic observations of all kinds. There's also the NEMI catalog for water quality analytes, or characteristics you're sampling water quality about, and the methods used to generate that data. And then the QUDT vocabularies has a lot of controlled vocabularies for quantities, so weight, mass, flow, temperature, things like that, units, and dimensions. And those can be really good for disambiguating, for creating, unambiguous metadata and data dictionaries for people. Rather than putting mg for milligrams, but maybe it's not clear if mg should be megagallons, right? You can use the very specific identifiers they have for all of these units to populate your controlled vocabularies and data dictionaries. So that was all about how to create metadata. But we also want that metadata to be published, presumably, whether internal to an organization or if you're going for an open public data. Two ways to publish metadata are in data catalogs, which are platforms to publish and manage metadata from many data sets in one searchable catalog. And the other kind of way is to embed microdata. Let me go back. Embed microdata in your actual data set website. So if you're running a data system that actually has landing pages for individual data sets already, similar to, say, the USGS string gauge pages, it can be useful to embed that microdata, which looks like this, from using that schema.org set of standards to embed metadata there so that search engines can can index your data pages and direct people there when they search for it in general. Okay, so some metadata publishing tools, some examples. There are some full service metadata catalogs that actually operate on top of data repositories. So they not only publish metadata, but your actual data. And so in academia, we have this Dataverse concept that many universities run, if you're part of a university. And then Jared Bales, in the presentation right after me, is going to talk about HydroShare, which is CUAHSI's data repository. And that helps you directly enter metadata, curate metadata, and publish metadata. There's also, and so those are services that you would kind of upload data to. If your organization doesn't already have a data catalog and doesn't want to rely completely on some sort of external service, there are also several options to make your own data catalog or instantiate your own data catalog. So one prominent example, which is an open source version, is CCAN. I'll end the show so I can go to the link. Are people just seeing my screen? Is Ashley there?
Yeah, I'm seeing your screen. Mm-hmm.
Okay, great. So let's go to the link. So an example of CCAN is the New Mexico Water Data Initiative's data catalog. So, which looks like a nice website. And it's a searchable catalog where you can search something like, wells, and find a bunch of data sets about wells. And in each page, there is some metadata, some descriptive metadata, and some administrative metadata, as well as a link to where to find that data and download the raw data. So CCAN in general looks like that. And it's very common. It also underlies the data.gov federal system. There are also vendors that provide more managed versions of that. Another example is GeoNode, which is really optimized for geospatial data. So this is the World Food Programme's geospatial data catalog. And it operates pretty similarly to CCAN, where it has all kinds of interesting data sets in there that you can sort by category or search by keyword. And can also embed things like the data dictionaries if you were to go to it. This one is not being very responsive right now, so we won't. Here we go. And so this is an example of a data catalog that embeds metadata like the data dictionary directly with the data set for easy use. In this case, they haven't populated it very well. Nevertheless, the option is there. Socrata also is a paid platform, very similar to CCAN. So data.colorado.gov runs on Socrata as an example. And then for those organizations that already have Esri subscriptions, Esri has a product called ArcGIS Hub that fulfills this same function. And so this is the North Carolina Department of Environmental Quality's version. And they all look pretty much the same. So those are all good examples of that. And for thinking about embedded metadata, the best guidance from that actually comes from the search engines themselves. So for instance, Google Datasets has this guide here at this link for how to mark up your web page so that they can crawl it. And they go into pretty detailed information that you can pass to your IT folks for how to embed structured metadata to describe your data set on the internet. And finally, if you want to think about publishing feature level metadata, I would encourage people to look into the new OGC API features, which is the successor to WFS, for people who know what about that is, which is an API standard that includes how to embed metadata within geospatial features. And I'll stop there for questions, if there's any time left.
We have time for one or two questions if anyone has any. There was one question that was in the Q&A and then you answered it in the next slide, so it disappeared. So, but just want to pause for just a moment to give anyone a chance to type into the Q&A. Okay, so if you think of a question, we can circle back around at the end, Kyle, and we'll go ahead and move forward with Jared Bales, who's going to be, there was actually one question. Kyle, can you talk about generating metadata for spatial or temporal data?
Sure. So in general, for spatial data, you'd want to use probably one of the Federal Geographic Data Committee or ISO 19115 standards. And that's a good reason to use a data catalog, many of which have an extension for geospatial data. So I'm pretty sure the ArcGIS Hub catalog, and I know for certain GeoNode, when you upload data to them, it's already defined in the user interface. When you upload data, it has all of the fields for that metadata that you can put in. And that's a good way to learn what metadata elements are necessary.
Okay, great. Thank you. And now Jared Bales will be talking about CUAHSI's HydroShare. And just as a reminder, Lily has posted again in the chat the link to the meeting materials for Jared's demonstration today, should you need access to them. So Jared, I'm going to turn it over to you to share your screen.
Okay, thanks. Let me get set here. Let's see. So are you seeing the presentation mode or the notes mode?
The presentation mode is perfect.
Good. All right. Thanks. So, you know, this partnership among the Internet of Water, CUAHSI, and WAVE is really valuable. And so we're happy to be a part of that. I think we each bring different strengths to the table, and we have made some really nice advances together. And these workshops that we've been doing are part of that. So CUAHSI, you know, people mispronounce their names some, so here's a phonetic spelling for you, but we are a nonprofit consortium, but everything that we have and everything that we do is available to the community. And so all of our code, for example, is on GitHub. All of our, you know, videos and so on are available for viewing. Lots of material available for download. And so we do try to build a community in the water resources arena. You know, hydrology is really just a relatively young discipline in terms of being its own discipline. I think probably around 1990. And so about 10 years later, NSF said, you know, we need to help build community around the hydrologic sciences, and CUAHSI was born. And so we have kind of two main service areas. One is community services and one is data services. And so community services are things like training, short courses, cyber seminars, and so on. And so we encourage you to sign up for our newsletter that's on our website so that you can learn about those things. So there's some things here that maybe are repetitive from what Kyle said, but I think they're worth repeating at some level. So CUAHSI supports fair data as much of the community does. So that means the data are findable, accessible, interoperable, and reusable. And so metadata are clearly important for fair data. And so, you know, CUAHSI through this data lifecycle supports each kind of step along the way. And the data management plan is an important place to begin. as you think about your data for particular activities. I mean, for many of you, you have ongoing monitoring and so on, but data management plans to kind of describe these essential elements can be important. And you see again that components of the data management plan kind of feed into these things that Kyle was talking about in terms of metadata and accessibility. And so if you want to see a data management plan, you can go to this Hurricane Maria data management plan. It's on our website at CUAHSI.org. So also there are templates available to help you create data management plans. And so here's one template that I've listed here, but then there's also CUAHSI has some tools to help you create your own data management plan. So these are valuable in terms of describing the metadata and the schema and so on, as you kind of build out your system. And so Kyle already talked about this, but that's okay. Schema is the elements used to capture the information. Standards tell us how to populate the schema. CUAHSI uses Dublin core data and it's schema.org. Schema.org makes the data discoverable through this Google dataset search that Kyle also mentioned. But in terms of this findable, accessible, interoperable, reusable idea, metadata make your data interoperable across systems. And then, as I said, we use the Dublin core metadata standards. We use ODM2 for one of our data systems, data technology, and we use Dublin core for HydroShare. And so again, links in here to access those things. So, and I think it's at the end, or no, in the shared folder, there is a list of all of these URLs. I think it's labeled useful resources or something like that. So you don't have to, of course, copy these down. And now I'm going crazy here. But so they're in that shared folder if you want. So let's go to, let's think about one of our data systems, which is the hydrologic information system, which runs off of something we call a hydro client. But the hydrologic information system uses a very structured metadata schema, the ODM2, very structured, very detailed, lots of information. It takes a fair amount of effort to populate the metadata for that. But we use that schema for this particular technology because it's really helpful in discovering data. And so here we have an image of our hydrologic information system, which is used to discover and store and publish time series data of any type. It can be gridded data, it can be point data. And so, for example, you can discover global massive data sets on here and download them. And so at this point, let's get out of the presentation and where's stop share? There it is. and go to the website data.quasi.org. And I hope you will follow along. It will be more useful to you perhaps if you do that. So here now is.
Jared, I just want to make sure you want to share your screen, right?
Yes.
Okay. Right now you're just.
Yeah, I know. So let's see. What am I? Do you see the website at all?
Yep. Yep.
Okay. Good. So let's go to data.quasi.org. And just pan over to the US. And you'll see down here that there are 3.6 million time series discovered. And in fact, this system can't download and display that many. So let's go to Boston, which is where I am. So I hope you're sort of following along and doing this yourself. It's not that hard. All right, so now let's get some data. And so let's get dissolved oxygen data. And so this is kind of where this metadata comes in. We could look over here at the full list, and there's just lots and lots of data here, right? So water level data, ice data, snow level, and so on. But right now, we're going to pick dissolved oxygen, and we're going to search. And here's what we found. So 4,100 data sets for dissolved oxygen. So let's just hover over one, and here you can see that we have data from INWIS or USGS. We have data from the Ipswich River Watershed Association, the Taunton River Watershed Association, Muddy River Water Quality Monitoring Project, Boston Harbor and Mass Bay, and then we also have daily values from USGS as well. So you can hover over these particular clusters of data to see who's providing the data, to see if that's what you want. So let's look at the data services. And so this just lists all of the data services that are in HIS. But if we want to look for Boston, then we find here's a data service that provides data for that has the name Boston in the title. And if you scroll across here, let me go back. Well, you can, if you scroll across there, you can kind of get more information about that particular service. And then, so I'm going to go back through this. and we're gonna get the data, or at least display them, right? So here is a selection, and so we can take that one and we can select it, and then if you want, you can download, you can make multiple selections and download the data all to one data set. So here's sort of, you know, the metadata about that particular site. So, you know, sampled in water, hydrology, quality control, who collected it, when's the start and stop date, and so on. So this is a technology that allows you to discover lots of time series data from all over the world. And as Kyle mentioned, the metadata catalog is of value, could be of value to you, even if you don't use the interface to download data, because you can discover the data and then you can go get the data, you know, in other ways. Okay, so now let's see. Gotta go back to the presentation. All right, so we did that.
Jared, there's one quick question here that says, what is the quickest way to get the data dictionary in this case, for example?
The data dictionary would be back here for the ODM2 catalog. So that's I mean, this is on GitHub. There's also on the CUAHSI website, there are links to the ODM2 schema catalog as well. Okay, so we did that. So now let's think about data more broadly, right? So all hydrology data are not time series data. So for, you know, we could have a map, we could have a shapefile, we could have a video of, you know, of a flood. So data comes in all shapes and sizes, and so we need something more than you know, a time series database to store these data, to make the data fair, right? So the workflow is I mean, kind of the basic workflow for data creation is, you know, you create a digital instance, you want to share it with your colleagues, maybe privately at first, right? So you don't make your data public immediately after the data are collected. You may work with your colleagues on the data, whether it's revising the data or building out some value-added products. You describe your data with the metadata, and then perhaps you share your data and even publish it with a DOI so the data set can be cited. And so this is what HydroShare really enables. And so the basic HydroShare workflow, which is, this is off of the HydroShare website, just essentially follows those steps that I just described: create, upload, describe in metadata, share with colleagues, and publish it. And it's essentially any kind of file that you want to upload. I mean, this presentation is stored in HydroShare. And so you'll see lots of those kinds of things. You'll see raw data, you'll see models and model instances and so on. And so this is kind of the resource level metadata that's associated with a KEO critical zone observatory site, right? So this particular data set is stream water chemistry up here. These are the authors. This is the published DOI, so the data can be cited and found. Here's the ORCID IDs for the authors. Where did the data come from? How was the data, how is the data collection supported? How do you cite the data? So these are the authors, and this is how the data would be cited. Here's the spatial information, and here's a map showing the KEO there in El Yunque National Forest. So, these are the kinds of, and this is Dublin core metadata. So these are the kinds of data that these folks created when they created this data set. So pretty straightforward, but it makes the data interoperable, as we said. And then the other thing, sorry about this, about HydroShare is that we have, in HydroShare, we have resources, groups, and communities. And so a resource, you could think of it as like a file folder for a particular project, right? So it has, in this particular case, we have different data sets in this resource. And then that resource is named and metadata are included and so on. We also have, the users can create a group in HydroShare. And so this Water Hack Week group is for, a selected number of people. And so again, you can think about it like a Google folder in which only certain people have access to the folder, either to read it or to edit information in the folder. And so CUAHSI now, we must have well over 50 groups that have been created in HydroShare for people who are working on different projects and activities. But it's a way that you can control who has access, control, who is collaborating with you on your data before you're actually ready to publish the data. And then finally, we have communities, and we actually only have one community at this point because it was created as a one-off for the critical zone observatories. And so all of the data, you can discover all of the data from the critical zone observatories, about 10 years of data, 10 plus years of data from 10 sites, all, the critical zone data from the bedrock to the treetop kind of thing. So you can discover all of that in HydroShare now. In some cases, the resource points to an external location where the data actually are held. So for example, Lukio, I believe, uses USGS streamflow data, so there's no need to repeat those data back in, in HydroShare, but one of the resources just points out to NWIS and says, okay, here's the data. And so that's, but the metadata catalog makes those data discoverable.
Jared, there's 2 questions.
Okay, thank you.
Are all data sources created in HydroShare accessible using HydroClient?
So no, HydroShare and the HydroClient are 2 separate systems. Aspirationally, we want to connect them. We want to connect them at least at the level that one could go into HydroClient and search for time series data and find time series data that are stored in HydroShare and vice versa, but they do not currently talk to each other.
Great. And the second question is, how do you assess level of data use after publication?
Right. So actually, CUAHSI has we've got a, our funding agencies ask us that question too, because they want to know if their money is being put to good use. But so we developed with another project, essentially a web crawler that looks for the citation or for the word CUAHSI or for the word HydroShare. And so we can then find at least where those data have been cited, right? So, and we also know how many times a data set has been downloaded. There's some, there's lots of discussion in the community about, papers, white papers and reports. We count how many times those have been cited, but we don't count, in terms of sort of our personal metrics of growth or performance. We pay less attention to how often data have been cited or reused, and there's a lot of people advocating for, that's just as important as a research paper, those reusable data sets. Okay, so
it looks like we just had one more question pop up.
Yep.
Are there some APIs for access to these data?
Yes, so HydroShare has a number of APIs that you can download. You can access HIS using a R-based tool or a Python-based tool, and likewise with HydroShare, APIs are available and described on the HydroShare website. And so
for now, sorry.
Yeah, no, that's perfect, because it kind of leads into this slide in which I kind of wanted to show how APIs are used to access HydroShare data and then use those data in other applications or apps. And so currently built into HydroShare are apps to connect to, I think the ones in particular would be of interest is MATLAB Online. And so, MATLAB normally requires a license, but because they're down the street from us and we've developed a relationship with them, users can access MATLAB Online through HydroShare, and users also can access Jupyter notebooks or a Jupyter Hub, which is on Google Cloud, and Binder as well, which is a tool for kind of transferring software. And so a little bit more about Jupyter. So in this particular case, we have this national water model subsetting tool that's described in HydroShare, but then we can, through this didn't quite come out in the right order, but we can collect using that subsetting tool in LDAS data and then build a Jupyter notebook in which you can share your code and you can, put in narrative and describe your code, and including, this how to run a wharf hydro simulation. So the Jupyter notebooks, if you aren't familiar with them, you know, they are a very powerful tool that are available directly in HydroShare, so that, you know, a user can access data in HydroShare, build some code in a notebook, you know, to analyze the data, or, you know, perform some modeling on the data in the Jupyter notebook, and then share that notebook with colleagues. And so not only does it, you know, make it easier to do that kind of sharing, but it also creates a reproducible workflow, right? So you can go back and see what you did, and others can repeat it. I mean, I think, you know, you probably all worked with data and models enough to know that unless you document things along the way, it's easy to forget exactly how you came up with that model parameter, for example. And so, you know, Jupyter notebooks are useful also in educational applications. This is one that was done for a hydrology modeling class by Irene. And so it's shared in another application called HydroLearn, which actually is not part of CUAHSI, but it links to CUAHSI resources. So here is kind of a slide for support, right? So there's lots of online support activities. Again, these are links to these are included in your shared resources. So now let's go to a HydroShare demo, but I think there's a question.
Yep, there's one quick question, Jared. What kind of raster data are available in HydroClient or HydroShare?
So nothing in HydroClient. And in terms of what, so there are some raster data in there, but I don't know what they all are. I mean, so they're what people have submitted or published in HydroShare. And so one way to go in there is, one way to find out is to go in there and search, you know, for GIS or raster or maps or, you know, whatever search terms might work the best. But again, HydroClient is time series data and time series data catalog, and that's it. HydroShare is any kind of data that, you know, one wants to store in there. I think there's even a poem that someone wrote and has stored in there. So that's really not the highest and best use of it, but it's in there. So I'm going to stop sharing a minute and get to the website. Okay, so here again is where I hope you will follow along. I hope you have gotten your HydroShare login. You don't have to have a login to use HydroShare, but you can do more things. There's certain things that you're limited on what you can do without your login. And so I think it probably knows, yeah, that it's me because I come back here a lot. All right, so this is the front page. Here's that image that I shared with you earlier about how to, you know, or basically the steps of HydroShare. So let's do a couple of things in HydroShare. And again, these are, you can follow along on the screen yourself. You can, there's steps that I think I shared with Ashley that you can follow as well. So here we are. We're going to discover Hurricane Harvey data, right? So up here, HydroShare, we're going to discover. And so now this is essentially everything that's in HydroShare. And so this is, you can hover over these resources and see what's, how the resources are described in the, with the metadata. So we're going to look for Hurricane Harvey. So here's a bunch of, looks like about 47 different resources in HydroShare, 47 right here in HydroShare related to Hurricane Harvey. But I want to see a specific data set that was created by David Arthur. And so I'm going to click on his name, and now we filtered it down a bit more. And so if you look here on the kind of along the side, this is just kind of a standard set of data, composite resources, and whereas this is a collection, and so a collection includes a number of composite resources or file folders, right? And if you think in terms of that hierarchy. This shows that those data have been published with a DOI, and this shows that the data are, or the kind of this, the coverage, the area that's impacted is mappable. And so let's go to the Hurricane Harvey data collection. I guess collection is what we want. And so here's kind of the home page for that, with the whole area that's actually impacted, because within the data we actually have the hurricane track that goes over here. And then these are some citations, and then here is a story map that was created in HydroShare using data that are stored in HydroShare. And so, for example, here, we look at using the Esri story map tools, kind of the overview, the storm track, the flood data. These are places where we have flood information and so on. And so then these data can be downloaded. They're linked here, and so they can be downloaded if you want. So that's a pretty easy, straightforward discovery. So is there a question? No,
I don't have one in the Q&A right now.
Okay. All right. So, are there any questions about this? About this fairly straightforward? We kind of knew what we were looking for, and so we went there and got our data. All right. So now let's go back. To discover, and let's look at something where we don't really know quite what we want, but let's look for soil moisture data. All right, so we have 193 files with soil moisture data. So we can hover over them and see, what they are, a description of it. It comes from the abstract and the metadata. So let's map the data. Let's see where we have data here. All right, so here you see kind of the map where most of the soil moisture data are. This one right here actually, believe it or not, I think must be like the center of the globe, because it's on the equator, and it must be kind of spherically, or what's the right word? I can't think of the right word, but it's the center. And this data actually is SMAP data, right? So it's a global data set from NASA. And so that's why it maps out here in the ocean off the coast of West Africa. All right, so we're gonna go back. We're gonna hide the map, go back, and we're gonna pick this BCCZO data set. So this is from, actually doesn't, you'd have to go down further, but this is data from the Boulder Creek CZO. So we'll go to that page. And so now you see, again, the metadata. So here's the abstract, which is a piece of the Dublin Core metadata. These are the different sensors that are there. These are keywords that were created. This is the location of the Boulder Creek CZO. And then we have this readme.md file, which is the metadata overview. And so here we go with, the abstract, creator, contact, and so on. So that's part of this resource. The XLS file is actually the data. You can't view the data in HydroShare, so you have to download the data. And so you would hit the download button here to download those data. And let's see, download it. Yeah, that's the other thing. It downloads it as a zip file. Some time depending on it. Okay, here we go. So we downloaded it. File's big. It's taking an Excel a while to open it, so we'll kind of skip past that. So then the other thing to notice here, there's the metadata file, here's the descriptor file. So remember I mentioned that some of the resources point to external websites. And so that's this little arrow in here says, okay, we're pointing to some other website, and so it redirects me there, and you can get the data at that location, or get other data at that location. So the data are not only in HydroShare in this Excel file, but you can get additional data through this external site.
Jared, a question is, can you give some guidance on creating a story map in HydroShare?
No, I don't know how to do that. And maybe Kyle can answer that question, but I presume it's no different than creating a story map and then uploading it to HydroShare. But I don't have any personal experience in creating story map. Do you, Kyle or Otto?
I don't have any experience with making a story map in HydroShare. However, maybe we should put a pin in that and think about creating like a demo.
Okay. Yeah. Okay. And so that Excel file finally downloaded, but you know, you've seen lots of Excel files. All right. So let's do one more thing now. We're going to go back to HydroShare, and I'd like for you to try to create a resource. And so this is kind of where you're on your own. I'll kind of walk you through a little bit of it, but so create, and you're going to create a resource. And you can see the other things that you could create: a collection, which has a bunch of resources in it, a web app, a model instance, and so on. So we're going to create a resource, and we're going to give it a title. Probably 5,000 resources in HydroShare named test, but we're going to do it anyway. All right, so here's the landing page for my resource. And so I can type in the abstract. I can put in the keywords. I can put in the spatial area. You can kind of draw it in, or you can make a point if you have a lat long for it. Put in the temporal data. And then you just drag and drop your file in here. And so it's that easy to upload your data to HydroShare. You can add additional metadata. You can say how, if there are other references that you want to add. And then this is how this particular resource could be cited, right? So that would be a citation if I chose to use it. Now, you want to control who can see it. So this little guy right here tells you who you will give access to, right? And so right now, I am the only one who has access, but I could give access to other people here. And again, it's just like Google folders. They can view the data, they can add data, and so on. That's important as you think about sharing your data. And so can view, can edit with the owner. The other thing to think about is this decision here about, are the data public, which means anybody can download your data. Discoverable means that they can find the data set in the metadata catalog, right? So if you were back when we were discovering soil moisture data, you could find that those data are there. You could read about them in the metadata, but you could not download the data. And then private just means, you and whomever you have chosen to share the data with can access the data.
Hey, Jared, we have a question. Does HydroShare mine real-time data sources such as NWIS automatically?
No, it does not. So HIS does that. So, right, we connect to kind of I would call corporate data sets, or data servers who have web services that we can access via APIs. So we automatically update the metadata catalog, for example, for the USGS stream gauge network every week, and then the data are streamed into HIS more or less real time. So if USGS put in a stream gauge on Wednesday and we don't update the catalog until Sunday, then those data wouldn't be discoverable until the following week. But that's kind of the way we do all those services, including, for example, NASA data, NLDAS kinds of things, and so on.
Can I point something else out, Jared?
Yeah, sure.
So by using the CUAHSI API, so say if your organization has some sort of real-time data stream that you would like to be represented in HydroShare for some reason, it's possible to use the HydroShare API to automate the posting of data to a HydroShare resource, if that's something of interest.
Yeah, thanks for that, Kyle. Right, and so, for example, Otto's colleague, Jeff Horsburgh at Utah State University, does that for a sensor network that he operates in an experimental watershed. So, yeah. Okay, excuse me.
Sorry, there's one other follow-up question. Is it a requirement for the people you share? Is it a requirement for the people you share the created data with that they be registered on HydroShare?
Sorry, I had to get rid of my cough in there. So I don't know. I've never tried that, but I don't think so. I think as long as there is an email address, a valid email address, they can, they can be shared with. But, excuse me, but creating a login to HydroShare is really easy. Well, actually, that's not it. So I can't do it because it already knows me. But it's really easy. There's there's really very little PII associated with the login. We ask you who you're affiliated with. We ask you about your career stage, and that's about it as far as I recall. So it takes 30 seconds, just like in any other, but of course, we all have 500 different logins.
I think one person says they believe someone does have to have an account after all.
Okay, well, that's, I accept that. I said I have not tried. Mine are either discoverable or published. Okay, there's another question.
Can you add special data viewers or apps to HydroShare apps library?
Yes.
Okay, I thought that might be all for now.
Okay, so yeah, I mean, there in HIS, for example, there are visualization tools that are built on the R platform, and there's some of those in HydroShare as well. But the easiest way to do that is through the Jupyter notebooks. So that's, well, there's another question.
How do you delete a data set that you created, like this test data set?
Right, so as long as you don't publish the data, you don't hit the publish button. So let's see if we can go back. So that data set's not even discoverable in the catalog now because we didn't publish it. So let me see if I can go there real quick and show you how to publish it. So if you didn't, like I said, if you didn't publish it, it's not there. So I think we have to fill all this out before we can actually publish it. So as long as you didn't publish the data set, then the data aren't going to be there. Okay, so that's that's what I have, Ashley. Thank you all for the questions and for following along. I couldn't tell if you were following or not, but I hope you at least had a chance to click through some of this stuff. And if questions occur to you overnight, then we can address those tomorrow as well.
That's great. Thanks, Jared. And also thank you, Kyle. And for those of you tomorrow for part 2, we'll have Adil Abdullah from the Water Data Exchange from the Western State Water Council with an introduction to WADE and then a demonstration of the WADE dashboard. And then Kyle Onda, again, the data architect for the Internet of Water with a demonstration of tools on discoverability. We hope you all will come back and join us tomorrow for the second part of this workshop. If you have additional questions, please feel free to post them in the Q&A here. And we can post them then in the forum. Let me actually share my screen so I can give you the link to the forum. Jared, do you want to stop sharing your screen and I will share mine and we'll. Okay, so if you would like to follow along in the forum, you can enter the forum here. You can also go to the Internet of Water's website, internetofwater.org, to connect and peer-to-peer workshop. And that's where you can enter the forum as well. And you should see a place for this webinar. Thank you again, and we will hopefully see you tomorrow.